Welcome to Two Projects. In this video, we are going to explain the project Deep Learning Based Anomaly Detection for Fog Assisted IoVs Network. Introduction. The project focuses on addressing the security challenges within the Internet of Vehicles, that is IoVs network, specifically in the context of fog assisted IoVs, that is FAIOVs. As IoVs become integral to intelligent transportation systems, ensuring secure and efficient communication is paramount. The primary concern revolves around security threats and anomalies that can compromise the integrity of data transmission and communication in vehicular networks. So, the project employs deep learning based anomaly detection to enhance the security of fog assisted IoVs. By leveraging advanced machine learning techniques, the goal is to detect and mitigate security issues such as authentication breaches, data integrity compromises, distributed denial of service attacks, and malware threats. The methodology involves developing a robust anomaly detection system that can adapt to the dynamic nature of FAIOVs, ensuring a swift response to evolving security challenges. With the rapid expansion of IoVs networks, ensuring their security is critical. The project addresses the limitations of existing security measures, particularly in the fog computing layer. Fog computing acts as an intermediary between IoVs and the cloud, addressing issues related to latency, mobility, and location tracking. However, security concerns, especially at the local fog nodes, pose a significant challenge. The project aims to enhance the security of fog assisted IoVs, thereby contributing to the overall reliability and safety of intelligent transportation systems. And the project's outcomes have far reaching benefits for various stakeholders. It directly impacts users and owners of IoVs by providing a secure environment for data transmission, computation, and storage. Additionally, improved security measures contribute to better road safety and transportation services. The broader society benefits from a reduction in traffic accidents as secure fog assisted IoVs contribute to smooth and reliable communication among vehicles. Ultimately, the project addresses the pressing need for robust security solutions in the evolving landscape of intelligent transportation systems. Objective of the project. So, as I mentioned earlier, the initial goal is to deploy a range of machine learning and deep learning algorithms, including SVM, random forest, decision tree, NAI based DNN, and CNN autoencoder. This diverse algorithmic approach forms the core of our anomaly detection system for fog assisted IoVs, ensuring a comprehensive and robust security strategy. The aim is to assess the performance of each implemented model. We focus on key metrics such as accuracy, precision, recall, and F1 score. This thorough evaluation helps identify the model that not only effectively detects anomalies but also strikes a balance between true positives, and false negatives for optimal performance. Following the selection of an anomaly detection model, we aim to optimize its functionality, specifically addressing concerns such as false alarms. This optimization ensures the model's reliability in real world scenarios. Subsequently, we seamlessly integrate the optimized model into the fog assisted IoVs network. This integration involves ensuring compatibility with existing infrastructure while fortifying security measures against emerging threats, thereby enhancing the overall safety and reliability of the intelligent transportation system. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of law of work. So the first step is important required packages. So in this initial step, essential libraries such as NumPy, Pandas, sklearn, and TensorFlow with Keras are imported. These libraries provide foundational tools for data manipulation, machine learning algorithms, and neural network development, setting the stage for subsequent tasks. The second step is exploring the dataset. So the project involves the exploration of KDD dataset. This exploration phase includes tasks like loading the data, understanding its structure, and conducting initial data analysis to gain insights into the dataset's characteristics. The third step is data processing. Here, the dataset undergoes processing. Utilizing Pandas data frames and Keras processing, unwanted columns are dropped for a cleaner dataset. This step ensures that the data is well prepared for further analysis and model training. The next step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label encoding using label encoder. Here we apply label encoding to convert categorical labels into numerical format, facilitating the training of machine learning models that require numerical input. The next step is feature selection. In this step, feature selection is carried out using select percentile with mutual information classification, optimizing the dataset for model training by retaining the most informative features. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning, while the testing subset evaluates the model's performance on new data. The next step is training and building the model. In this step, various machine learning and deep learning models, including SVM, random forest, decision tree, Naive-Bayes, DNN, and CNN autoencoder, are trained using the training set. Each model learns patterns and relationships within the data, paving the way for diverse approaches to anomaly detection. And in the next step, as an extension, a hybrid model is created by combining predictions from multiple individual models. This ensemble approach enhances prediction accuracy and robustness by leveraging the strengths of each constituent model. And as an extension again, a user-friendly frontend is developed using the Flask framework. The next step is Flask framework with SQLite for sign up and sign in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information, and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users provide input through the front-end interface. The input data is pre-processed to prepare it for prediction by the trained models. This pre-processing step ensures that the user-provided data is in a suitable format for the model. And the pre-processed user input is fed into the trained model for prediction. The best performing model is selected to make predictions based on the input data. And the predicted outcome is displayed through the front-end interface, allowing the user to view the results of the model's predictions or analysis. Now we'll understand about the algorithms used. So the first algorithm built is support vector machine, that is SVM. So SVM is a powerful supervised machine learning algorithm used for classification and regression tasks. It works by finding the optimal hyperplane that best separates different classes in the feature space. SVM is effective in high dimensional spaces and is particularly useful when there is a clear margin of separation between classes. In the context of this project, SVM is employed for its robust classification capabilities to discern normal behavior from anomalies in the fog assisted IoVs network. The next algorithm built is random forest. Random forest is an ensemble learning algorithm that constructs a multitude of decision trees during training. It operates by aggregating the predictions of individual trees to enhance overall accuracy and control overfitting. Random forest is resilient to noise in the data and can handle a large number of features, making it suitable for complex datasets like those encountered in fog assisted IoVs anomaly detection. Its ability to capture complex relationships in the data contributes to its effectiveness in this project. The next one is decision tree. Decision trees are versatile algorithms used for both classification and regression tasks. They make decisions based on the values of input features, creating a tree like structure of decisions. Decision trees are interpretable and capable of handling non-linear relationships. And in this project, decision trees are employed to identify patterns in the data, aiding in the detection of anomalies by traversing the feature space through a series of decisions. The next algorithm built is Naive-Bayes. So Naive-Bayes is a probabilistic algorithm based on Bayes' theorem. It assumes that features are conditionally independent, simplifying computations. Despite its naive assumption, Naive-Bayes performs well in various classification tasks. In this project, Naive-Bayes is used to model the probability of an observation belonging to a particular class, making it suitable for anomaly detection by assessing the likelihood of observed events. The next algorithm built is deep neural network, that is DNN. So DNNs are a subset of neural networks with multiple hidden layers between the input and output layers. They excel at learning intricate representations of data through hierarchical feature extraction. In the context of this project, DNNs can automatically learn complex patterns in fog assisted IoVs data, enabling sophisticated anomaly detection by capturing nonlinear relationships and dependencies. And the last algorithm built is convolutional neural network, that is CNN autoencoder. So a CNN autoencoder is a variant of neural networks designed for feature learning and data compression. It consists of an encoder and decoder that work together to recreate the input. In this project, a CNN autoencoder is used for unsupervised feature learning and dimensionality reduction, aiding in the identification of anomalies by capturing essential information while filtering out noise in the IoV's network data. Now we'll see the comparison graphs of the algorithms. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have KDD cup dataset with 5 different class labels: normal, DDoS, probe, U2R and R2L, on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is the model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained model. This is notebook.ipynb file. This file contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address local host, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link. Click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password, and click on login button. So it has redirected us to the anomaly detection page. So here we have to fill in all these parameters and click on predict button to get the classifications. So first we'll understand these parameters. The first one is protocol type. It identifies the network protocol used in the data such as TCP or UDP. Service specifies the network service being accessed or utilized. SRC bytes represents the number of bytes sent from the source. DST bytes represents the number of bytes received at the destination. Logged in indicates whether user is logged into the system. Count refers to the number of connections to the same host. SRV count represents the number of connections to the same service. SRV different host rate calculates the rate of connections to different hosts for the same service. DST host count counts the number of connections to the same destination host. DST host SRV count counts the number of connections to the same destination host and service. DST host same SRV rate calculates the rate of connections to the same service on the destination host. DST host different SRV rate calculates the rate of connections to different services on the destination host. DST host same SRC port rate calculates the rate of connections from the same source port to the same destination port on the destination host. And the DST host SRV different host rate calculates the rate of connections to the same destination host but from different source hosts and services. So now we'll fill in these parameters. I have entered the parameters. Now click on predict button. So here we can see the result, that is there is no attack detected. It is normal. So for this set of parameters, the application has detected it as normal. Click on home link. We'll try giving another set of parameters. I have entered the values. Now click on predict button. So here we can see the result, that is there is an attack detected and the attack type is DDoS. So similarly, we can give any set of parameters and can get the detections. Click on home link. We'll try again. I have entered the values. Now click on predict button. So this time the attack has been detected and the attack type is probe. Similarly, according to the given parameters, we can also get the detection as U2R and R2L attacks. Now click on sign out. So the conclusion here is the diverse set of machine learning and deep learning algorithms, including SVM, random forest decision tree, naive-based DNN, and CNN autoencoder, demonstrated their effectiveness in anomaly detection for fog-assisted IoVs. Each algorithm brought unique strengths to the table, contributing to a comprehensive and robust security solution. Rigorous evaluation using metrics such as accuracy, precision, recall, and F1 score allowed us to identify the most efficient anomaly detection model. Optimization efforts addressed limitations, enhancing the model's performance and reliability in real world scenarios, especially concerning false alarms. The extension of implementing a hybrid model aggregating predictions from individual models significantly improved prediction accuracy and robustness. This ensemble approach leveraged the strengths of different algorithms, providing a more resilient solution to detect anomalies in the fog assisted IoVs network. And the integration of a Flask-based frontend coupled with SQLite for user authentication ensures a secure and user-friendly interface. This platform allows users to input data, observe the pre-processing stages, and receive clear outcomes from the trained models, enhancing accessibility and usability. And the project's ultimate goal of enhancing security in fog assisted IoVs is underscored by its real world applicability. By addressing security concerns and deploying advanced anomaly detection techniques, the project contributes to the overall safety and reliability of intelligent transportation systems, fostering advancements in the field of vehicular networks.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.